Today we're going to work on the standard derive using similarity the fact that the length of an arc intercepted by an angle is proportional to the radius, and derive the formula for the area of a sector. Our learning target will be to determine the length of an arc in the area of a sector. We want to be very comfortable with the formula sheet because this will be on your EOC using this two parts, area and circumference of the formula sheet. We want to review, determine the circumference of a circle. Make sure you locate the word circumference on the formula sheet. In this question, it's given us the diameter all the way across the circle is 8. So to find the exact value, we would say C stands for circumference equals pi times diameter, which is your first formula here. So in that case, that's going to give me pi times 8, which is 8 pi. That is our exact answer. So to find our approximate value, we're going to hit 8 times pi, which is above the times 10 to the x button. And make sure you hit your SD button to get your decimal equivalent. 25.1 would be rounded to the nearest tenth. Second example, if we determine again the circumference of a circle, locate the circumference part of your formula sheet. In this case, I'm given the radius instead of the diameter, so I would use the second formula. So I would say C stands for circumference equals 2 times pi times the radius. In this case, that's 5. If I put that in my calculator, I get 10 pi. That's my exact value. And to find the approximated value, be sure to hit the SD button. So that's going to give me 31.4 if I round to the nearest tenth. So now I want you to find the circumference. Here's an example. It wants us to find the exact circumference of a circle with a diameter of 26. You have a verbal instead of a picture. Another practice problem. Again, find the exact circumference with a radius of 15. Now, we want to use this to determine the length of an arc. We already know how to find the measure of an arc. It's in degrees. And the measure of arc AB would be 90 degrees because the central angle is equal to 90. So I want to use the fact that they're similar. So I'm going to say part of the circle, the arc, is 90 degrees. And the whole circle is 360 degrees. And remember, similar objects are proportional. So I'm going to use a proportion. I want to find the length of the arc, so that's the part. And I want to use circumference to find the whole distance around the circle. So I would use my second formula. So I would say 2 times 5, and in this case the radius is 6. So to solve a proportion, I want to cross multiply to find the cross products. So 360 times x is 360x. And if I multiply 90 times 2 times pi times 6, that gives me 1080 pi. So to solve for x, I'm going to use the division property of equality and divide both sides by 360. So when I do that, I get my answer is 3 pi. So my arc length is 3 pi. If I want an approximated value, remember all you have to do is hit the SD button. So that would be approximately 9.4 rounded to the nearest tenth. Again, determine the length of major arc ACB. I've highlighted that in purple. Now I know that the minor arc AB is 90. So to find the measure of major arc, I need to say 360, subtract 90, and that's going to give me the major arc measures 270 degrees. So if I want to find the length of the arc, you got to use the fact that they're similar. So I'm going to set up my proportions. So the arc, the part of the arc is 270 degrees. The whole circle is 360 degrees. I want to find the length of the arc, and I'm going to compare that to the circumference. Again, I'm going to use this formula. So I would say 2 times pi times the radius, which is 5. And to solve it, I'm going to cross multiply. So that would give me 360x. If I multiply 270 times 2 times pi times 5, that's going to give me 2,700 pi. And then I want to solve the equation. I left off my x. So I use the division property. I divide both sides by 360. So when I divide by 360, my answer, the length of the arc, is 15 over 2 pi. That's my exact amount. If I want to know the approximated amount, all I've got to do is hit the SD button. So that gives me 23.6 if I round to the nearest tenth. Now, I want you to find the length of arc AB using the fact that they're similar. So set up your proportions and get your answer. Remember, you're going to use the part of the arc, 135 over 360. You want to find the arc length. So we use the circumference formula. In this case, I would say pi times 20. And I'm going to cross multiply to solve that. Next one, find the length of arc AB. So there's my arc. Set up your proportions and solve. So in this one, I would say 40 over 360 equals x over 2 times pi times 4. Cross multiply to solve. Now, find the length of arc BC. So I don't know the degrees, but I do know the angle ADC is congruent to angle BDC. So I know a whole circle has 360 degrees. If I subtract 40, that gives me 320. Since the angles are equal, I can divide by 2 to get the measure of each one. So that gives me 160. So I know that the measure of arc BC is 160. Set up your proportion and solve. If I want to find the length of BAC, I want to go from B to A to C. I already know this is 160 degrees, AC. So use that fact to set up your proportion. So I would add 40 and 160. Set that over the whole circle. I want to find the arc length, and I've got to use my circumference formula for the distance around the circle. Cross multiply to solve. Find the length from A to C to B. From A to C to B. Make sure you find this measure for the arc and set up your proportion. So that would give me 320 degrees for the part, 360 for the whole. I want to find the part for the arc, 2 times pi times 4 for the circumference of the circle. And cross multiply to solve. Now we're going to do something different. I want to determine the area of the circle. So I'll make sure I use the area formula in my formula sheet. There's your circle. So if I want to find my exact value, I would say A stands for area, pi times r squared, which would be, my radius is 5 squared. So if I put that in my calculator, I get 25 pi. That's my exact value. If I want to find my estimated value, I hit the SD button. So that would give me 78.5 if I round to the nearest tenth. Again, I want to determine the area of the circle, so make sure you use the area formula of your formula sheet. So it tells me area is equal to pi times the radius squared. So I would say area equals pi times the radius squared. In this case, I don't know the radius. I know that the whole diameter is 6, and I know the radius is half of that, so my radius would have to be 3, because half of 6 is 3. If I put that in my calculator, I would get pi times 3 squared, and that was going to give me 9 pi. If I want to find the approximated value, I would hit the SD button, and that would give me 28.3 if I round to the nearest tenth. Now I want you to use the area formula to find the area for this circle with a radius of 7. Again, I want you to find the area, so use the formula sheet to find the area of the circle. Now we want to use that to determine the area of the shaded sector. Now a sector is just a piece of a circle. I've got that shaded in purple. So again, we're going to use the fact that they're similar. So we're going to set up our proportions. So the part of the circle is 90 degrees. The whole circle is 360 degrees. I want to find the shaded sector, that's the part of the circle, and I'm going to use my area formula to get the area of the whole circle. So I'd say pi times 5 squared. And then I would cross multiply to solve my proportion. So that would give me 360 times x equals 90 times pi times 5 squared. So that's going to give me 2,250 pi. And then to solve for x, I want to use the division property of equality. So I'm going to divide both sides by 360. So when I do that, I find the area of the shaded sector is 25 over 4 pi. And remember, that's my exact value. So to get the approximated value, I hit my SD button, and that would be 19.6 if I round to the nearest tenth. Another example, determine the area of the shaded sector. So make sure you use the area part of your formula sheet. Remember, a sector is a part of a circle indicated by the purple. So I want to use my fact that they're similar. So I'm going to set up my proportions. The part is 30 degrees. The whole circle is 360 degrees. I want to find the area of the sector, which is part of a circle. And I'm going to compare that to the area of the whole circle. So I'm going to say pi times 6 squared. And then I cross multiply to solve any proportion. So 360x equals 30 times pi times 6 squared. So that's going to give me 1,080 pi. And then to solve the equation, divide both sides by 360 using the division property of equality. So that gives me the area of the shaded sector is 3 pi. And that's the exact value. To find the approximated value, hit your SD button, so 9.4 rounded to the nearest tenth. Now, I want you to determine the area of the shaded sector using your formula sheet and the fact that they're similar. Set up your proportions. Part over whole equals part over the whole area. Determine the area of the shaded sector here. It might be easier if you use 4.5 in place of 4.5. On this one, find the area of the shaded sectors formed by angles ABC. Notice all three angles are congruent, so I would divide 360 by 3 to find the angle measure. Set up your proportion. Again, find the area of the sector. So you're going to set up your proportion. You need to find the angle measure first. Here's some multiple choice examples. Make sure you use the correct part to find the length of the arc. Again, a circular quiche, that's an egg pie with a diameter of 9 inches, is cut into 6 equal slices. What is the area of the top? I would draw a picture here.